So, uh, good morning, everybody. I'm Miriam from SOS Electronics, and today we are holding a Sensirion webinar. This webinar we prepared due to Sensirion became one of the top brands in our portfolio, and we have real big interest from our customer. So that's why we are decided to hold webinar for this brand. I would like to say that this webinar will be recorded. So after this webinar, you can find whole presentation on our website. Also, I would like to say that if you have any question regarding the topic, please write your question to window Q&A. And if you have any other question, please contact the admin. So one more time, welcome everybody, and I would like to pass the word to our presenter, Mr. Vincent from Sensirion.
Hello, can everybody hear me? Yes, hello and good morning. Dear attendees, ladies and gentlemen, thank you very much for joining this webinar. I am very happy to have the opportunity to talk to you about simple and accurate measurement of humidity and temperature with Sensirion sensors today. So let me just quickly start my presentation. Just quickly, admin, how can I share the presentation?
Okay, so hi Vincent, there is a big button on this quick start and share my...
Okay, I got it, yeah.
Okay, perfect.
Okay, so I hope now everyone can see the start screen of my presentation. So the topic today will be simple and accurate humidity and temperature measurement with Sensirion sensors. First of all, I would like to quickly introduce myself. My name is Vincent Hess, and I'm responsible for product management for humidity and temperature sensors here at Sensirion. I have a master's degree in mechanical engineering from ETH in Zurich, which is the Swiss Technical University. And I've been working for Sensirion for the last 7.5 years. The first 5 years I spent in R&D doing project management for humidity sensors, and now I've been in product management for the last 2.5 years. Here a short overview over the webinar today. I would start off with a short company information, then go into a short introduction of physics of humidity. Then I would like to present our humidity sensor product portfolio, then go to some hints and tricks that you need to know for humidity measurement, and finally show you some market trends and some specific application examples. And finally, I will show you where you can find all relevant information. So let's start with the company information. Sensirion is a Switzerland-based sensor company. The company was founded in 1998, and just 2 weeks ago we had our 15-year anniversary. We had a big party, so quite important date for us. Headquarters is in Switzerland, in Stäfa, which is near Zurich, and we have different sales offices worldwide, so we really we have a global presence. At the end of 2012, we had 500 employees. Today, it's already 550. We are growing very quickly since the beginning, and this growth is still going on. The core of all our sensors is what we call CMOSense technology, and we will hear a little bit more about this later on. And generally, we apply a very high level of engineering in order to achieve a low cost and high quality production. The markets that we are present in are very diverse, so a lot of different markets that we sell our products into. This is just an overview over the, say, most important ones. So appliance is a market which is increasing strongly. Consumer electronics, of course. Then the automotive market is very important for us, also for humidity sensors. Medical market. Then, of course, building technology, and also industrial solutions. So with our different sensors, we cover a very wide range of markets. So what kind of sensors does Sensirion produce? Here is an overview. One, of course, is humidity and temperature sensors. Then we also do liquid flow sensors, differential pressure sensors, mass flow meters for gases, and mass flow controllers for gases. And what we also do is our customer-specific solutions. And today's webinar will be about humidity and temperature sensors. Okay, so let me go into the physics of humidity. I will not go into too much detail, but I think it's important to understand some basic concepts about humidity in order to be able to use a humidity sensor effectively. So what is humidity? With humidity, we mean the presence of water vapor in air, and water vapor is a gas. So it's not liquid water, but it's single water molecules in a gaseous form. So water vapor is a gas, and it's in our environment. Water vapor is everywhere. It makes up about 1% of the gases in our atmosphere. So if we have this water vapor, normally it originates from liquid water. We have evaporation, where the water molecules go from a liquid state into a gaseous state, and there is also condensation, where the water molecules go from the gases state, from the gases. Can you hear me, or just hear that there is a problem?
We can hear you.
Okay. I got a chat that someone cannot hear me. Okay, so I just go on. So there's condensation, where the water molecules go from the gaseous state into a liquid state. And now the ability of the air to accommodate water molecules is very much temperature dependent. So if we look at the same situation in a closed box, so we have a closed environment with liquid water here at the bottom, and we wait for a long time, we will finally have an equilibrium state. So the evaporation rate, so first the water molecules will start evaporating. There will be more and more water molecules here in the gases state. There will be also condensation, where the water molecules go back to the liquid state, and after a very long time there is an equilibrium where the evaporation rate is the same as the condensation rate, and in this equilibrium we say the air is saturated with water. So the maximum amount of water that the air can accommodate is reached. And this maximum amount is very much temperature dependent. So if we have a higher temperature, there will be a lot more water molecules, a lot more water vapor in the air in case of saturation. So this is a very important fact, and this can also be visualized by this graph. On this axis we have the temperature, and the green line indicates the saturation vapor pressure, and this can be understood as the maximum amount of water vapor that can be accommodated by the air. And here what's very important, you can see at low temperatures this amount is very small, so only very little water can be accommodated by the air, and at high temperatures a very high amount of water can be accommodated by the air. And this relation is not linear, so it's not something like this, but it's exponential. So the temperature actually makes a very strong difference. Now, if we talk about humidity, there are different ways to describe humidity, and the term that is most commonly used is relative humidity, RH, and the unit is percent RH. Now, the definition of relative humidity is the actual amount of water vapor in air, so the actual amount that we have in a certain situation, divided by the maximum possible amount of water vapor in air. And this is given in percent, so it's a percentage. And if we visualize this in this graph, the blue dot would then be our, say, actual conditions. At 30 degrees, we have a certain amount of water vapor, 20 hectopascal, for example, and at this temperature, the maximum possible amount would be 40 hectopascal. This is this green line. So the relative humidity in this situation is 50%, because it's exactly half of the maximum possible amount. If this blue dot would be up here, it would be 75%. If it would be down here, it would be 25%, for example. So it's really the percentage of the maximum possible amount of water vapor in air. So this can be also visualized with these dotted lines, the different percent humidity levels. Now, what is very important is that our sensors, they measure relative humidity and temperature. And it's always important when you have a relative humidity measurement or information, it's always important to know at which temperature this was measured, because the temperature makes a strong difference. Another very often used term for describing humidity is the dew point. It's TD, and it's actually a temperature, so it's given in degrees centigrade, but it is a measure for the humidity. And the dew point is actually the temperature at which air becomes saturated with water. So if you have a room, for example, again, we take this blue dot, 50%, we have learned on the slide before, at 30 degrees. So we have to, the dew point indicates to which temperature do we have to cool down this air now, these conditions, until we reach saturation. And in this graph, we can simply go on a horizontal line to the left until we reach this saturation vapor pressure curve, and then we can see at which temperature this is. And for these conditions, 50%, 30 degrees, the dew point would be approximately 18 degrees. So it's really the temperature at which the air becomes saturated with water. And this is also a very commonly used term for describing humidity in practical life. And here what's important is that our sensors do not measure directly the dew point, but the dew point can be calculated from relative humidity and temperature, which our sensors measure with a relatively easy formula. Okay, so here's a slide with the just most important things about this part. Humidity is everywhere. It's in our atmosphere, and it is relevant to many different aspects of our everyday life. Humidity describes the presence of water vapor in air. There are different definitions of humidity, and the ones that are most commonly used are the relative humidity and the dew point. And very important, relative humidity is highly temperature dependent, and for this reason it's important when you measure relative humidity, you should always know at which temperature you measure it. So I think a basic understanding of the physics of humidity is very important in order to use a humidity sensor effectively. Okay, so I would like to go to the next section and introduce our humidity and temperature sensor portfolio. First of all, our humidity sensor, they are based on a capacitive measurement principle. So they are polymer-based capacitive humidity sensors. This means that the sensor consists of a capacitor which has a humidity-sensitive polymer as a dielectric. And this polymer soaks up water molecules according to the ambient humidity, and this makes the capacitance, makes a change of the capacitance of the capacitor, and that's what we basically measure. So in this illustration, what you can see is our capacitor. We have a special capacitor structure which consists of interdigitized electrodes. The reason is that this can be very easily integrated into a chip on a planar surface, and we have a polymer, which is the green thing, which coats these electrodes, and here are the water molecules that are abundant in the environment, in the environmental air, and diffuse into this polymer, and finally make a change in capacitance that we can measure. Our sensors are based on CMOS technology, which means that we integrate the sensor elements and the complete readout circuitry on one single CMOS chip. So our humidity sensor structure is completely integrated in a CMOS chip, and this has a number of advantages. Firstly, it allows us to make the whole sensor very small, because we have just one single chip, and we can make all the structures very small. We can since we can use this CMOS technology, which is the standard technology for integrated circuits, it allows us to make the sensors very cost effective and also to produce them in high volumes. And also the fact that the sensor elements and the readout circuitry are located on the same chip allows us to have a very high precision and little noise in the signal conditioning, so which results in a very good sensor performance. Finally, our sensors are very easy to use. They provide a fully linearized, fully calibrated, temperature compensated output in a digital format. So there is no need for the customer to do any kind of calibration or linearization of the signal. You just have to apply a simple linear conversion formula to calculate the physical values. So the first humidity sensor that we launched was about 10 years ago with this CMOS technology. And in the meantime, we have gained a lot of experience in the field, and we have constantly evolved and enhanced this technology for the last 10 years. Now, if we look at different markets that we address with our sensors, we can see that it's very, very diverse, and we have different products in our portfolio which target different ranges of markets. So here on the left-hand side, we have the SHT7X, which is a pin type product, which is more aimed at high-end measurement and test applications. Then we have our SHT1X, which is more for industrial, HVAC, and home appliances. We have our SHT2X, which is, I would say, our flagship product, targeting automotive, medical, but also home appliances. And then here on the very right-hand side, we have a very dedicated product, SHT-C1, which is clearly targeted at consumer electronics and mobile devices. I will go into more detail for the different product lines later on. Now, most of these products we provide in a different accuracy grade, and this is always the same naming that we use. Yet now for the SHT1X, for example, we have the SHT10, 11, and 15, where the SHT10 is the most low cost, least accurate product with an accuracy of plus minus 4.5%, and the SHT15 is the most accurate product with an accuracy of plus minus 2%. And depending on the product line, we have all these different accuracy grades or just single ones. So and the naming is always the same. So it's a very very comprehensive and widespread product range. What we also have, in addition to the sensors, are filter caps for the SHT1X series and the SHT2X series. These filter caps, these are plastic parts with a humidity transmissive membrane on top, and they can be used if in applications which are really which have very, very harsh environments, and they protect the sensors from droplets, but also from dust and dirt. But they are really used in extremely harsh environments. In the normal environment, there is no need for filter caps. So we have these filter caps, and then of course we also have evaluation kits, 2 different evaluation kits which help to evaluate our sensors, to evaluate the performance, to make first measurements, and so on. So the SHT7X, as I said, this is really our high-end sensor. It's a pin type, so it's not for soldering, but for plugging into a connector, and it's a sensor with the highest available accuracy in our portfolio. It has a very specific design for best sensor performance with this very slim neck here that provides the best possible decoupling, thermal decoupling from the main PCB here. And also the pin type package allows for easy interchangeability. On this slide and also on the next slide, you will always find some product details down here. I will not talk through these, so you can just look at this if you're interested in that. Main applications for the SHT7X are really high-end lab applications or measurement and test devices. Then we have our SHT1X. This is our oldest product, but it's still very popular. We still sell it in high numbers. And this is really the product if you need a supply voltage of, or if you have a supply voltage of 5 volts. It's a very long proven performance and still running very well. And since the package is a little bit larger than our other products, it's a little bit easier to handle in assembly. Applications for the SHT1X product line are mainly industrial applications, home appliances, HVAC. So mainly markets which still use 5 volt as a supply voltage. Then we have our SHT2X product line. This is really our flagship product for a very large variety of applications. It's very small. It's in a 3 by 3 by 1.1 millimeter DFN package, so very small, enables a lot of different applications. It has a very low power consumption, so it's also very suitable for portable applications or battery-driven applications. The DFN package provides really very high reliability and long-term stability. And we provide this product in multiple interface options. So this one is not only available with an I2C interface, but also with a PWM interface or an SDM, which allows customers to easily convert the outputs into an analog signal. So this is also a benefit of the SHT2X product line. Applications, I would say this product can be used almost in any application, but for sure automotive is one focus for the SHT2X, but also medical and home appliances. By the way, we also provide this SHT2X type product as a temperature-only version, so a temperature-only sensor, which is called STS21 with the same performance, temperature performance as the SHT21. Then we have the SHTC1, which is a very specialized product. This was developed especially for consumer electronics and mobile devices. It's our smallest sensor. This one is only 2 by 2 millimeters and has a super low power consumption. And we have the capability to produce this sensor in very high volumes. But it is also kind of restricted to high volume applications, and the minimum order quantity for this product is 50K per order. So there are really target applications are consumer electronics, high volume consumer electronics, and mobile devices. Okay, then we have our evaluation kits. The evaluation kits, they are really useful to make a first contact with our sensors because they are just plug and play. You get sensors delivered with the evaluation kits that you can plug in. You get the viewer software, and you can instantly start measuring it and assessing the performance of our sensor. We have 2 different evaluation kits. There is the EKH4, which is kind of a measurement box where you can plug in up to 4 cables with sensors. So you can connect up to 4 sensors to an EKH4, and you have a viewer software with very extensive functionality. There are 8 sensors included in the EKH4 package. It's 4 SHT71 and 4 SHT21. So this is a very quite large evaluation kit. On the other hand, we have the EKH5, which is a very simple, small, and easy to use evaluation kit, which consists just of a kind of a USB dongle with one cable and one sensor that can be connected to the cable. So this is a very, very easy, very small, and a very easy first step to evaluate our sensors. Now I would like to quickly show a demo of the EKH5, so you can see what the viewer software looks like. I can just would like to show you how easy it is to get started with this evaluation kit. So this is the quick start guide, which is included in the kit if you order it, and it describes the steps that you have to go through in order to start a measurement. So very first you have to download the software, the viewer software from our website, which is very easy. Once you have installed it, you can connect the sensor cable to the USB dongle, and at the end of the sensor cable you can connect the sensor to the cable. The sensor is an SHD21 on a little PCB with connector pins. So this is included in the evaluation kit package. In the next step, you connect the USB dongle to the PC, then you start the software. You get a selection window where you have to select the product that you want to measure, and then finally you have the viewer window. So now I would like to switch over to the viewer window so you can see it. Just 1 second. Okay, so I hope you can see the viewer window now. Here on the top left, you have different options you can select. For example, you can set the sampling time, how often you want to make a measurement, from 1 second to a very long period. You can select the resolution of the sensor from 8 to 12 bit for humidity and 11 to 14 bit for temperature. You can select the temperature unit and also some timing settings. On this side, you have information about the sensor. This is an SHD2X that is connected currently, and you also have a serial number. Each of our sensors has a unique serial number, which is also displayed here. So if we start run now, you will see it starts measuring. The values are displayed here. Humidity on the left side, temperature on the right side, and you see currently in the room that I'm sitting in, we have around 46% and 25 degrees. So if I take the sensor now and blow at it, you will see how the humidity will increase, and also the temperature. So you see it goes up very quickly. You can also scale the amplitudes here to have a better resolution of the picture. Same here. So you see the humidity goes up very quickly to over 90%, and it comes down also very quickly. So here with this evaluation kit, you can really easily make first measurements and assess the performance of the sensor. What you can also do is you can log the whole data to a file. So you can select the file where you want to store it, and then you can just simply start logging, and all the measurements will be stored in a file. So you can start and stop, and I will quickly show you what the file looks like. Okay, here we have a log file with different columns. You have the sample number, so the number of the measurement point. Then there is, of course, timing information and relative humidity and temperature data. This is a CSV file and can easily be imported into Excel, and you can make any kind of plots or graphs. Okay, so yeah, I think the evaluation kits, they are really very useful for making first contact with our sensors. One big advantage is also that you have a quite long cable with the sensor at the end, so you can put the sensor into a climate chamber or into a measurement box or even into a device that you want to test it in. So it's very useful. Okay, then one word to quality. Sensirion is certified along different ISO standards. So of course ISO 901, we have the certification, but also the automotive certification ISO TS 16949 and the environmental certification 1401. And since we are delivering our products into the automotive market, but also into the high volume consumer electronics market, where the customers have very high demands on quality and also on supply chain reliability, we have a very high redundancy in our production facility and in our production processes. So now you have learned a little bit about the physics of humidity. You have learned about our product portfolio. The next topic I would like to address is do's and don'ts in humidity measurement, and some tips and tricks that you need to know in order to use a humidity sensor successfully. So the first topic I would like to address is design in. So how to design a humidity sensor into a device. Because I think in most applications, our sensors, they are designed into some kind of devices with a housing. And there is some things that you need to consider or need to know. So first of all, very important is a humidity sensor always measures its immediate surroundings. So it measures the humidity and temperature right around the sensor. And in most cases, when a humidity sensor is designed in or located in a housing of a device, it's actually supposed to measure the environmental conditions. So this is what is illustrated in this figure. We have a sensor here, which is mounted on a PCB. We have some kind of device housing, and we have the environmental conditions. And in most applications, the sensor which is inside here is actually supposed to measure environmental conditions. And in order to achieve, or let's say, in order to achieve the optimal performance, the design in has to be really well, because the best humidity sensor with the best performance does not perform well in the application if the designing is bad. And when I talk about performance here with the designing topic, I mainly talk about accuracy and response time. So response time means how quickly does the sensor react to a change in environmental conditions. So as I said before, the sensor mainly or always measures its local conditions, so the conditions right at the sensor, but it should actually, or is intended to measure the environmental conditions. So you have to make sure by making a good designing that the local conditions are as close as possible to the environmental conditions. And this can be reached by a possible coupling to the environment and best possible decoupling to the inside, to disturbing effects from the inside of the housing. And this applies both to humidity and temperature. So on the next slide, I will give some guidelines for optimizing the humidity performance. So first of all, of course, there needs to be some kind of opening in a housing. Otherwise, the sensor cannot measure environmental conditions at all. And a very simple but important rule is to maximize the opening. So the larger the opening in the housing, of course, the better the sensor has access to environmental conditions. This is quite obvious, but still it's important to think about it. Then the next thing is to minimize the dead volume. And when we talk about dead volume, what we mean is the volume that the sensor is located in behind the opening. And so you can imagine if we have a change of environmental conditions here, the conditions in this whole dead volume need to adapt to the environmental conditions so that the sensor can measure actually the new environmental conditions. And so the larger this dead volume is, the longer this will take. So if you want to have a quick response time, you really have to minimize the dead volume the sensor is located in. And as a third rule, it's important to seal the dead volume towards the inside of the housing. So you have to prevent air from the inside of the housing to go into the dead volume and to go to the sensor, because the air which is trapped inside the housing, it will change very, very slowly to changes of the environmental conditions. And if you have always a little air from the inside of the housing going to the sensor, there will be always a disturbance. So this has to be sealed as good as possible towards the inside of the housing. Now, if we look at temperature performance, the most important thing you should know is that the main thermal contact of the sensor happens through the backside. So the thermal contact does not happen mainly through the top, also a little bit, but it's mainly thermal conduction through the PCB and through the substrate of the sensor to the chip. So actually what the temperature that the sensor measures is the temperature of the PCB. So if you want to measure environmental conditions, you need to optimize the thermal coupling to the outside. So ideally you could make some kind of a thermal conduction path towards the outside. And what's also very important, you have to decouple the sensor from internal heat sources. So very often you have on this PCB, you have other electronic devices like a microcontroller or maybe some RF components which create a lot of heat. And there it's important to decouple the sensor from these heating components. And this can be, for example, done by having slits in the PCB or by reducing the width of the copper traces and so on. So this is also very important for the temperature performance. There are also some processing guidelines. Basically, our sensors can be processed with standard reflow, soldering. Rehydration may be required if you want to have a functional or a humidity test right after the soldering process. If there is no need for a humidity test right after the soldering process, then the sensor will recover and rehydrate by itself over a couple of hours or days. Then exposure to chemicals should be avoided in a high concentration or over a long time, because of course this polymer is not only sensitive to water molecules but also to other kinds of volatile organic compounds. So you should really avoid high concentration and long-term exposure to chemicals. Coating is always a topic, so conformal coating can be applied, no problem, but obviously you have to make sure that the sensor opening stays free of the coating. Otherwise, the sensor will not measure anything anymore. And generally, materials that are in contact with the sensor, like housing materials or packaging materials, they should be selected such that they do not have a too strong outgassing of chemicals, which could influence the sensor. There is a document called Handling Instructions, which is available for download at our website, which includes all this information in detail. So what you should remember is mechanical designing is really critical for sensor performance. A humidity sensor can only perform as good as the designing is. So very often the designing is the limiting factor. The awareness for these processing guidelines is important. And for detailed information about these topics, we have documents on our website. We have a designing guide for humidity sensors, and we have handling instructions for humidity sensors. And I will show you later on the website directly where you can find these documents. So then I would like to show you some market trends that we see. Some market trends that we see, and also some application examples. So Sensirion is a sensor company, and our big vision is sensing anytime, anywhere. And at the moment, what we see is really a big trend to include sensors in electronic devices, and really in any kind of electronic devices. This is really something which is strongly increasing. This trend is enabled on one hand by smart and small energy efficient sensors, also affordable sensors, of course, which can really generate data, but also by low power wireless connectivity solution, which allows to connect these different sensors. And of course, today processing power is almost for free, and this allows to compute meaningful information out of this sensor data. And of course, with our sensors, we try to make them as small, as smart, and cost-effective as possible to contribute to this trend. But we also try to make sure that they are suitable for low power wireless connectivity, so that they have a very low power consumption, and that the data processing is as easy as possible. So the sensors provide really fully processed digital output signals. Now, the main drivers for using humidity sensors are, on one hand, health, comfort, and well-being, because humidity has a strong influence on our personal well-being and also on our health. And humidity cannot be felt as easily, or is not as intuitive as temperature, for example. So it makes a lot of sense to help people with humidity sensors, so they can really see what's the humidity in their environment. Then humidity also has a large impact on different processes or on quality of things, such as combustion or the quality of sensitive goods, for example, in transport. So this is also a big driver. Then, of course, driver for any kind of sensors is always energy saving, making processes more energy efficient. And finally, also safety is an important aspect. For example, our sensors are used for fogging detection on car windshields. So they help prevent fogging in the first place, and so they contribute to the safety of driving. Now I would like to mention some specific examples. The first one is a very interesting one, I think. Not very obvious, but really very interesting. It's the use of an SHT71 in a display case, just a simple display case, in this case for a supermarket. And these cases, they have the problem that sometimes this glass fogs up, so you have condensation of water on the glass. And currently, this problem is solved by using a temperature sensor and controlling some kind of heater just based on temperature information. But this temperature control is very ineffective and unreliable, because with a temperature sensor alone, you cannot detect the critical conditions. So the solution here is to use a humidity sensor and really detect the critical conditions. And the benefit is that you can actually use the heater more efficiently. And in this specific case, this yielded in energy savings of up to 90% compared to the old solution. So I think this is a very nice example. Then we have another example, more going towards building monitoring. We have a customer who includes the sensors, our sensors, in a kind of an RFID box, and this box is built into wooden floors. And the reason is that these wooden floors, when they are built into a house, they are very sensitive to humidity, and if they are built in too early, when maybe humidity of the concrete is still too high, they might take damage. And so the solution is to have this data logger box. It contains two sensors, one for the top side, one for the bottom side. And this box is really built into the floor, and you can access to the data with an RFID reader. And this allows the customer finally to log the temperature and humidity conditions over a long-lasting period, and to manage complaints more efficiently, and to find out reason for possible complaints. So in this case, also energy, of course, energy or power consumption of the sensor is very critical, since this is an RFID device. And the next application example is an HVAC thermostat. It's a very new type of thermostat. It's called the Nest, the learning thermostat, and it uses our SHT21 sensor. Now, classic thermostats are usually very user-unfriendly and kind of stupid, and this leads to the fact that they are used inefficiently. So the solution here is to have an intelligent thermostat with a lot of different sensors, including humidity and temperature sensor, which can automatically detect the behavior of the residents of the house, and finally automatically adapt the climate. And it can be easily controlled with a smartphone, so it's also connected. So I think this is a good example for a new class of devices that are kind of connected. They use a lot of different sensors. They communicate with smartphones and so on. I think this is really an increasing market, not only for HVAC but also for other home use devices. The benefits in this case are that you have improved energy efficiency and have up to 20% of savings in your heating and cooling bill And of course, the humidity sensor helps to provide a comfortable environment for the residents. Then one last example, which is also very nice, I think, is also going towards building monitoring. It is an infrared thermometer with a built-in humidity sensor, which makes possible to have kind of a mold alert function. The problem is that in buildings at cold spots, like near windows or at outside walls, temperature is lower than in the rest of the room. And as we have learned before, if you have if the temperature is below the dew point, then you will have condensation at these cold spots. And in the long term, this is a very high risk for the formation of mold. And mold is actually quite bad for your health, so you should really avoid it. Now, this customer built an infrared thermometer, so you can measure the temperature without touching or contactlessly at this cold spot, and the humidity sensor, which is built into the device, measures the ambient humidity and temperature. And of course, you can calculate the dew point value, and then you can compare the temperature of the cold spot and the dew point. And if the temperature is lower than the dew point, then you know there is a high risk of mold formation, and then you can start to introduce countermeasurements in order to avoid this mold. So this is also quite a nice application example. Okay, so I would like to quickly show you where you can find important information on our website. And for that, I would quickly switch over to my web browser. Okay, so I hope you can see my web browser now. This is the Sensirion website, the start page. So the easiest way to navigate is here on this top bar. You can go to Products, Humidity and Temperature Sensors. If you click this one, then you get an overview over all our different products. You have already here links to the data sheets, but you can also go to, there is a product page for each product with description and features and all the relevant documents related to this product here on the right side. So on this product sites, you can find all the product relevant documents. So you have all the humidity sensors here again on this navigation bar. You have the filter caps, you have the evaluation kits, and then there is also one very important page. You have a download center, and here this is a collection of all the data sheets and other technical or supporting documents for our sensors, and this is, I think, quite an important one. So you have all the data sheets, but you, for example, you also have sample code and software for the different sensors. You have CAD models, which help you integrate the sensor in your CAD design. You have some scientific support, introduction to relative humidity, and so on. Under key documents, you can find the handling instructions, the design guide that I mentioned before, but also other important documents like a testing guide for humidity. So it's really worth looking through these documents and seeing if you can find something important. Also find some more technical advice, certificates, and some very special applications demonstrated here. Okay, so product sites are important, and the download center that you can navigate to here. Okay, so I will go back to the presentation. So I'm at the end of my webinar now. I'd like to just quickly summarize what I have gone through. First of all, humidity is really everywhere in our atmosphere, and it has various effects. It affects our lives, and therefore it's in many cases it's important to measure it. Sensirion is the market and technology leader for humidity and temperature sensors. We have a very wide and innovative and comprehensive product portfolio, and actually you can find the right humidity sensor practically for any application. Our sensors are leading in terms of quality, reliability, and performance. They are very small, energy efficient, and we provide very high proficiency of support and technical expertise based on our more than 10 years of experience in the humidity sensor business. And finally, humidity and temperature sensing is key to increasing energy efficiency, guaranteeing process and quality control, and ensuring well-being and comfortable environment. Okay, so then I would like to thank you very much for your attention. Thanks for joining this webinar. And if you need more information, you can always check our website and, of course, also contact SOS Electronic. Thank you.
Okay, thank you, Vincent, for your presentation. So for now, we don't have any questions, but I would like to ask if there are any additional questions. You can anytime contact SOS by email, phone, or whatever. Also, I would like to, if you have a couple more seconds, we will be glad if you fulfill our short survey, and one of you will be drawn by a lot and can win an evaluation kit EKH5. So please write us your feedbacks or whatever you would like to share with us regarding this webinar, Sensirion. So, we have one question right now. So, what is the maximum pressure which RH&T sensors can withstand?
The maximum, like barometric pressure.
Yes.
I mean, basically, humidity, relative humidity is not pressure dependent, and since the sensors, they do not have any cavities or closed cavities, they are actually not pressure sensitive. I do not know, like in the very high pressure domain, probably there is a limit at some point, but generally I would say it's at least in the, say, barometric range that you have in the environment is for sure no problem. But also in higher pressure ranges, should be no problem to use the sensors. But I also have to say that we have not tested this, so yeah.
Okay, thank you. So I guess if this is all, so I would like to also point your attention to our next webinar next Wednesday. It will be dedicated to Quectel. And from tomorrow, you can register. So one more time, thank you, Vincent, for your presentation. Thank you, all of you, for your attention. And we will looking forward to meet you on our other webinar. Have a nice day. Bye-bye.
Thank you. Bye-bye.